Okay, so this is example 3 of solving systems of equations. And what we're going to do is we're going to solve this system of inequalities by graphing. In order for me to solve a system of inequalities by graphing, I would like to get y by itself in each equation. So to get y by itself in the first equation, I'm going to subtract 2x on both sides. And so I have 3y is less than or equal to negative 2x minus 6. And then I'll divide everything by 3. And so I have y is less than or equal to negative 2 over 3x minus 2. So there's my first equation. Now on the second equation, it's a good bit easier to get y by itself. On it, I will subtract x on both sides. So I have negative y is less than or equal to negative x plus 1. And then I'll divide negative 1 on both sides. Now, guys, you need to really be paying attention. If you divide by a negative on both sides, you got to do what to the inequality? I got to flip it. And so I'm going to have y is greater than or equal to x minus 1. And so those are the two equations that I'm trying to graph. Right there. So I've added a little graph paper and I want to graph these two equations. I'm going to graph the red one first. In order for me to graph it, I can see that the y-intercept is negative 2. So I'm going to put a point at negative 2 and then I'm going to go down 2 and right 3. So I'm going to go to negative 2 on the y-axis and put a point. And then from there, my slope is down 2 and right 3. Okay, I could also go up 2 and left 3, like that. And so I'm going to take, and looking at my inequality, would this be a solid or a dotted line? Solid. So I'm going to draw a solid red line. Oh, that's not a red line. I'm going to draw a solid red line, and I'm going to move it so that I'm connecting these 3 points. I drew 3. All I needed was 2, but the more you draw, the easier it is to connect them. Now let's graph the blue line. On the blue line, I'm going to go down 1, right here. And the number in front of x, when they don't write a number, is understood to be what? 1 over what? So our slope tells us to go up 1. Yeah, it tells us to go up 1, rise 1, and then run 1. So I'm going to go up 1 and over 1. And I'm going to go up 1 and over 1. And I could go down 1 and left 1, right? So I'm going to draw a blue line to connect all 4 of those points. And I drew a solid line because my inequality is equal to. If it wasn't equal to, I would have drawn a dotted blue line. Now, let's ask ourselves where to shade. Okay, let's look at the red line. Okay, the red line is right here. And does this inequality tell me to shade above or below the red line? Below. So here's the red line. I need to shade both sections below the red line. What I'm going to do right here is I'm just going to put a star where I would have shaded. Okay? So that what I'm saying is I would have shaded this whole area and this whole area, right? Now, let's put a star where I would have shaded for the blue line as well. Here's my blue line. Okay? Does the inequality tell me to shade above or below? Above, because it's greater than. So what I'm saying is here's my blue line. I'm going to shade above it. So here's one area above it and here's the other. So let's put a star in both. There and there. And then you just ask yourself, where is the double shaded region? Yeah, you can see the one with 2 stars right here would have gotten shaded twice. So it's the one that's going to get shaded. Okay? So I'm going to shade everything in this area right here. Okay? And so you guys know that the only way to solve a system of equations at this point is by graphing. And so if you don't have a graph, you didn't solve it, did you? Okay? Now, any point, well, first what I'm going to do is I'm going to delete the other stars because that shouldn't be shaded and that shouldn't be shaded. And then the question is, what is a solution to this system of equations? Any point that falls in the shaded area is a solution. Let me ask you this. What if I'm dead on the line right here? Is that a solution? It is. Why? Because it's solid. Let me ask you this. What if it's dead on the line over here? No, because this is not in the shaded area, is it? Okay? Any point within the shaded area is a solution. So this would be a solution. What point is that? What point is this right here? Negative 6, 0. So if I wrote down x equals negative 6 and y equals 0, I would get a true statement if I plugged it into both this and this equation, wouldn't I?